Okay, let's do a rocket example. So let's say that you are building a model rocket, and so you've designed your model rocket here, and let's say your model rocket is sitting on the launch pad, and you've designed it so that the initial mass is 3.25 kilograms, and you've put some solid rocket boosters in here, and they're burning here, and you can actually buy these things that burn at different rates. And so you can actually, there are commercial places you can purchase these little model rocket motors that burn at a particular rate. And so you design it so that the exhaust comes out here. So the exhaust is going to be at 321 meters per second. Okay, so slightly less than Mach 1. And so you want, when you fire this thing, you want it to have an initial acceleration of 21.5 meters per second squared upwards. And so what you want to do is you want to figure out what rate of fuel consumption are you going to need so that you can do that, so that you can go out and purchase the right one. I mean, yeah, you could probably design one, but it's just as easy to go buy one that's already prefabricated, little solid rocket things. If you try to make solid rockets at home, this is normally a very dangerous prospect. A lot of people injured themselves severely by trying to make solid rocket motors at home, because if they don't burn properly, they tend to just explode. And so you don't want that. All right, so you want to just go buy one. So that means you need to know the thrust. Well, to find the thrust, free body diagram, we have mg pushing down. Okay, we got the normal pushing up. Now that's what's happening when it's just sitting on the launch pad. Okay, now when it's accelerating upwards, the fraction of a second after it leaves the launch pad, then you still have gravity pulling down, but you do not have a normal. Instead, you have the rocket thrust pushing upwards. Okay, and it's accelerating upwards at this point, so sum of the forces equals ma, so the rocket thrust minus mg equals ma. So the rocket thrust is going to be ma plus mg, so in other words, that's ma plus g. So that would be 3.25 kilograms times 9. So I'm going to write that up here where there's more room. Okay, so that's going to be 3.25 kilograms times 21.5 meter per second squared plus 9.81 meter per second squared. So the rocket thrust is going to be 102 newtons. Now, you know that R times the exhaust velocity is going to be equal to the rocket thrust. So R is going to be Fr over V sub E. And so that's going to be equal to 102 newtons, okay, and that's divided by the exhaust velocity, 321 meters per second. And so R is going to be equal to 0.317 kilograms per second. Okay, remember, a newton is a kilogram meter per second squared divided by meter per second. So that's going to end up being a kilogram per second. Okay, so that is the rate of propellant burned and expelled, so a little bit less than a third of a kilogram per second. And so that gives you the kind of rocket motor you'd have to purchase for that particular rocket.